Okay, Kevin, thank you so much for joining us today. I would like to welcome you to the show.
Thank you. Thanks for having me. Looking forward to this conversation.
Awesome. So today I would like to talk to you about manufacturing execution systems, or MES in short, for data-driven manufacturing. Now, to begin, I would like to first get clarity on why the need to transition to data-driven manufacturing, as opposed to how manufacturers have been operating all along. What are the major factors that are influencing this need for data-driven manufacturing?
It's a good question and something that we talk about a lot. The manufacturing, from our perspective, is getting more and more challenging. It's not getting any easier. It's getting harder for all of the manufacturers out there. And when we look at the challenges that they have, I break them up into two groups. One is the short-term challenges that they have in the plant that they're dealing with every day: downtime, production, on-time delivery, quality, reliability and maintenance. All those same kind of challenges that they've had for many years, those exist. And sometimes they're getting even more difficult. And also, if we were to think about what's happening in the marketplace, the bigger challenges, what I think of as the longer term challenges, there's a lot more competition out there. There has been for a while, and it's still getting even more competitive. Supply chain issues also a challenge. Labor, hiring and keeping people in the plant is more difficult. Inflation. I mean, you just add up the challenges. And companies, to face and handle these short-term and long-term challenges, companies can't continue to use pieces of paper and spreadsheets in their plant to survive. They need to get more competitive. They need to get closer to the organization. They need to have more real-time visibility. And the way I think of it is right now they're operating based on the ERP system that's up here. They need to get that real-time visibility into the plant floor to understand what's going on. So it's those typical day-to-day challenges that they need to continue to solve, but solve them in better ways. And the bigger challenges they need to get data on to understand what's going on. And so to solve them, they need to get that data. They need to become data-driven organizations, and they do that by getting right to that plant floor. That's the shortest answer.
Okay.
Does that make sense?
Yeah, it makes a lot of sense. Makes a lot of sense. Now, before we dive deep into our topic of the day, I would imagine that our audience here have different experiences with MES systems. So maybe to set the foundation here, can you give us an introduction to MES, what it is, and why is it needed for manufacturing?
Sure, absolutely. It's a really good question. It's surprising how many manufacturers actually ask us that question as well. A lot of them don't really know what an MES system is. So when I think of an MES system, we can think about it a number of ways, but I'll keep it very simple. Again, we've got the plant floor, and we have the management office, the corporate strategic office up here using an ERP system. Now let's think about it. Sales will sell a sales order. They'll convert that sales order in that office to a work order. Then how do they get that work order down to the plant floor? And how do they create the bill of material and get that to the plant floor? How are they scheduling that software? How are they scheduling when and how to manufacture that product? Once it actually gets to the plant floor, then how are they organizing three big things? How are they organizing the people, the machines, and the raw materials to manufacture that product? While they're manufacturing it, how are they doing? Are they performing well? How many parts have they created? How much have they scrapped? And what are some of the other performance metrics so that the people in the carpeted office at the ERP level can understand how they're performing? All of that functionality, all those capabilities are right there in the middle. And if you think about it again, a lot of companies are still operating based on pieces of paper and spreadsheets in this middle layer. And again, you don't get very much real-time connectivity to understand what's going on. So it's how companies will organize the people, the materials, and the machines to manufacture their products. There are typically 11 different functions that are in the MES system, but when we think about it, we don't get too complex with the answer. We talk with companies and find out that typically they want to start off with just a few capabilities. They want to understand their unplanned downtime and why their machines are down so much. They want to get OEE and break that OEE down into its components, availability, quality, and performance. And then they want to typically manage their work orders. And sometimes they'll start to ask early on for scheduling as well. But it's those components that are typically the first things that they ask for, and the ERP system doesn't do it. So that really becomes the MES. One other way that I'll mention briefly to think about the MES is that it's the model of how the manufacturing plant works. What machines do you have? What people do you have? What lines do you have? What products are you producing? How are you producing them? Batch, process, or discrete? What's your typical process? Quality? There's so many different pieces that come into play for that. And we can get into some of the more detailed conversation about an MES, but at a high level, it's the model of how that manufacturing plant works to organize, again, the products or the raw materials, the machines, and the people to get the product out the door. Does that help?
Yeah, absolutely. Certainly does. Certainly does. So maybe let's get into a little bit of detail here. You mentioned that there's 11 functions that MES executes on. Can you please describe to us what those functions are?
Sure. So MESA has defined this a nonprofit industry-focused organization, international organization, has defined 11 basic functions or capabilities that should or will typically happen within a manufacturer. And I'll also mention organizations like ISA and MESA aren't trying to tell manufacturers what to do. What they are typically actually doing is identifying patterns and coming up with best practices. I mean, they're at least defining what companies should do by looking at manufacturing across the globe to understand what are the best ways to do things. And when we talk about that middle layer of a company and how to connect the plant floor with their top of the organization, usually those companies will want to do data acquisition. They'll want to acquire data from the people, from the machines, and understand what's going on. They will want to schedule their production and understand what's going on. They have to manage the personnel in the plant. Again, remember, it's the organizing the people, the machines, and the raw materials. So they need to manage the personnel. They also need to manage the resources, and the resources could be the raw materials and the machines themselves. You often want to watch the flow of the products through the plant or the flow of the batches and how the product is produced. You want to get into track and trace, being able to track the source of materials, who worked on it, operators, what machines worked on it, and be able to sometimes create a genealogy of how that product was produced, especially for products that are used in really important and valuable industries like aerospace, airplanes. I want to make sure that bolt that is holding the wing to the plane is going to stay there so that I can have my nice safe travel to wherever I'm going. Or for the pharmaceuticals, the drugs that I'm putting in my body, I want to make sure, I want to have some kind of assurance that that product is a good product. Or if it ends up being a bad product, that we can figure out why, and we can trace all the way back to the original manufacturers of those base products to understand what went wrong. Quality control is another one. Process management, managing the processes within the plant. Performance analysis. Remember, I talked about reporting that data back up to the ERP. How did we do? The quality, the scrap, the performance, product counts, etc. We need to report that information back up. Document management. There are a lot of documents to manage. Work instructions, blueprints, bills of materials, all kinds of things. We need some place to be able to manage that so that, again, we can organize how we're organizing the people, the materials, and the raw materials to produce the products. And then finally, maintenance is a big key as well, maintenance and reliability. And that usually comes in the form of a CMMS, a maintenance set of features or separate product.
Oh, awesome. That's very interesting. So you've done a very good job of explaining these functions. Now, what I would like to find out from you, Kevin, is How does an organization then go about selecting and implementing the right MES system for the job?
Well, I'm going to give maybe a different answer than what some people might give. I mean, obviously, the first thing to do in any kind of software selection scenario is to understand what a company needs. What are the business challenges? And maybe I'll just throw out as a quick reminder, in any situation we face, and in manufacturers, we try to remind them too, we make sure that we're looking at what is the business problem to solve. And then let's generate or create a hypothesis for how we think we can solve that challenge. And then once we believe we have a good hypothesis, let's figure out what information we need to solve that hypothesis. Once we have that information defined, then what data do we need to convert into information? I'm making a distinction between data and information. Information is processed, aggregated data, statistics, et cetera. Once we've defined what data we need, then finally we get to the technology. So when we're thinking about selecting an MES, the wrong thing to do is to just pick a product off the shelf because it's based on Microsoft and we're a Microsoft company, or it's based on, it can be hosted in Azure or in AWS because we happen to be a big user of AWS. Rather, what we should be doing is looking at the challenges we have. And I would recommend, even before starting to have that conversation, we step back even further to think about what's the vision of the company. And then when we think about the fact that we want to connect the strategic top of the organization to the plant floor, what we're really doing is becoming, as you've already mentioned before, a data-driven organization, a data-driven manufacturer. And if we're not very data-driven now, we want to move to becoming a data-driven organization. That means we're going through a transformation. I'll bring up that maybe overused phrase sometimes.
Yeah.
We are going to go through a digital transformation. And if we're going to do that, and if we're going to select technologies for an MES that are going to be with us for a long time, let's step back and think about what is our digital strategy? What's our approach for how we're going to make decisions going forward for the next 10 or 20 years? Not just 1 or 2 years to put this MES system in place, but let's figure out what our digital strategy is. How are we going to identify that value data is valuable for us? How are we going to actually utilize that value in the company? And where are we going to do it? Once we've defined that too, we should be defining what we often think of as a minimum technical requirements. What are the technology requirements that we have for us? So if we're talking about going down this path of a digital transformation, we need some guardrails so that we don't steer off the path and lose ourselves and waste a lot of money and waste a lot of time as a company. So let's define our digital strategy. Our minimum technical requirements gives us the guardrail to make decisions for any product we select. Then we look at our business challenges, and then we look at what I think of as 3 options for selecting an MES system. The first option is a monolithic big product. It takes 18 months to install. It takes several $1 million. It's a high risk proposition because there are so many things that have to go perfectly in putting this big application in place. And if a company isn't ready for that, number one, and number two, if that product is a generic MES system, then it's going to have to be heavily customized for that unique company. And that project has a high risk of failure. We have seen projects go south, have a problem, where there are some big applications or MES systems we've heard of that had to be canceled halfway through because the CIO said, you have overpromised and underdelivered on how easy it is to connect to machines and to other systems. Get out of here. So they've canceled, wasted a lot of money. On the other hand, we've actually heard success stories and are involved with ancillary, involved with a success story around that MES system being put in at a large company where we're based in Pittsburgh, Pennsylvania in the US. But it's because that product was specifically built for their industry and their sub-industry, does exactly what they need, and they have an awesome project manager making sure that that project is completed. If that high risk, big dollar number or euro number or whatever currency number project can't happen, then look at the second option. The second option for putting an MES system or the start of an MES system is to find a small production monitoring system. What I think of as a limited point solution. They're really nice and they work really well for small to sometimes mid-sized companies. But the challenge with them is that they have a glass ceiling. They're pretty easy and straightforward to connect to machines. They give you some nice graphs and charts, and sometimes you can integrate them with other systems like your ERP or your CMMS, your maintenance system. But they kind of stop at that point. They give you OEE and the breakdown of OEE, but at some point you're going to want more from your MES system. Track and trace, forget it. Does it have maintenance capabilities itself? Does it do scheduling? No, not at all. So you can't really call that an MES system, but many of those companies will actually think of them as an MES system. So I call that second category production monitoring point solutions. They are very focused on solving a specific problem. The third category is a category that we work in a lot, which is the built for you or custom MES. We start with or work with a standard small MES system that is customizable and scalable. It's built on some of the tools like TATSoft's Factory Studio product or Inductive Automation's Ignition product. Get that in place. It has those capabilities that companies usually want because they keep asking us for them. So we built a template project, which is OEE, downtime, work order management. We're going to be adding scheduling. Get that in place, solve those business challenges. You can get faster value to getting data out of a system. It's much lower risk, and then we can build on that over time. We can build out the specific solutions in Ignition or Factory Studio from scratch that meet their exact needs, or we can use best-in-class off-the-shelf systems. Let's find that best maintenance application out there. Let's find the best production scheduling application out there. And then let's integrate it with this whole unified namespace. Let's integrate it with the architecture so that everything fits together like a patchwork quilt. So that's what our solutions typically look like. Patchwork quilt fit exactly to what their needs are. And I'll give a quick example of a situation that we're running into. So there's a company has two different groups. One group is looking at getting the big monolithic MES system in place. What is it, October now?
Yep.
They said by the end of December, we're going to have that product selected. Well, then it's going to take them at least 1 or 2 months to go through the purchase process. Then it's going to take them 1 or 2 months to get through designing. And then it's going to take 18 months from there. So I think we're at the end of 2024 at that point by the time they get that MES system in place. The other group said, we want to get data by the end of December this year.
Yeah.
How do we do that? By starting small, basic capabilities, integrate with machines on a nice, flexible, scalable architecture, get going quickly. Who do you think is going to win the race to a better factory at that point?
Oh, interesting. So maybe let's take a look at the architecture aspect of it, because like a big part of our audience here are industrial professionals who spend a great deal of their time thinking about how to put these pieces together. So can you describe to us what an ideal architecture for an MES system looks like for you?
Sure, absolutely. I think I've kind of already touched on some parts of it, but I'll expand on parts of it, of course. So for us, when we're working with a manufacturer, we'll already have talked about and helped them define, of course, that digital strategy, those minimum technical requirements. And then we'll talk with them about this idea called the unified namespace, something that I think you talk about. And again, a lot of the companies out there listening probably understand the unified namespace. If you don't, there are a lot of recordings that Kudzai has done on unified namespace, and it's really great content. The idea of a unified namespace is to provide that single version of the truth. So I'm thinking, I'm connecting my machines, connecting my MES system, my ERP system, my CMMS, my scheduling system, whatever else I need into one system. I'm not going to put the ERP system at the center of the world and then have lots of discrete connections and siloed systems and all that, because the discrete connections be very difficult to maintain, If you want to swap out a system, you have to reestablish or reconnect all those different systems. Instead, put one data collection or a data connection hub in the middle, connect all the systems to that central place. So at that point, you have a single hub of communication that will provide you the current state of everything that's going on in that plant. And when I say everything, I mean eventually everything, not the first day, but eventually you connect everything to that hub. And then because you are pulling in the data from the PLCs, the MES, the ERP, you then define, using a basic idea from ISA 95 Part 2, you define the model of how that business, how that plant is operating by defining the and organizing the data by enterprise, site, area, line, and cell. So with the enterprise, think of, let's say, Coca-Cola. We have a site called Pittsburgh, where we're located. Let's think of an area called the bottling line. And within bottling line, or within the bottling area, we have line 1. And on line 1, we have a PLC. We could have multiple PLCs, but here in this situation, we'll just talk about the first PLC. And on that PLC, when we connect the data to the PLCs, we're then modeling that data and defining all those tags will be grouped, and you can visually see them in Ignition and Factory Studio right under that PLC in this whole tree view structure called enterprise, site, area, line, and cell. We'll have our MES system, maybe based at the line area or the area part of this structure. And then information we're exchanging and working with will be grouped under the MES system. And at that point, we're defining and then capturing and organizing the data based on this whole model of the business. So for us, the basic architecture of a manufacturing execution system starts with the unified namespace. It's a concept, it's an architecture that lives here. Then just underneath it, there's a layer of technology to make that possible, which we can get into. But then once we have that basic architecture in place, and we're able to connect those PLCs, then we can connect our MES. And the first thing we do, again, back to the architecture question, we'll take this template MES system, put that template MES system with those 3 capabilities in place, connect it to the unified namespace, and then we can have these PLCs publish using MQTT Sparkplug-B. Everybody really should watch Kudzai's video on MQTT Sparkplug-B. Awesome video. I've complimented him countless times on it. It's a fantastic video, great details. So publish data into that unified namespace, and then the MES system that we have, this template MES system, can subscribe to that data. So let's say that we want to publish data from the PLCs into the unified namespace. The MES system can take that data. It will calculate OEE, let's say, and then maybe people at the corporate level want to see the trends of OEE. So that MES system can then publish that calculated value out, and then a business intelligence system can then take that data and chart it over time, and we can hopefully see the very nice rise of OEE as we're getting much better data and real-time visibility into the organization. So the architecture is unified namespace, single hub of communication, which provides you the current state of everything in the moment, and a model of the business. We're connecting PLCs, MES, et cetera, everything else. We're then putting in place our template MES system with these few capabilities: OEE, downtime, work order management, and scheduling. And then at that point, we're building it out from there. Does that answer your question?
Yeah, absolutely. Absolutely.
Awesome.
So you brought up some interesting concepts there, unified namespace. So I would like us to touch on that a bit more in detail, including the tools that you could use to do that. But for now, what I would like to find out is you have described to us like the ideal architecture. Now, someone would ask, why can that be achieved using traditional data systems, right? So in other words, what are the problems with the current manufacturing data systems that make them not suitable for this kind of architecture that we've just described?
That's a fair question. I think I've, in a way, kind of touched on some of these points, but this is a good opportunity to really highlight them. Some of the problems for the architecture that companies have are that they will put, again, I'll use my hand as the illustration, they'll put the ERP system conceptually. The IT departments will put the ERP at the center of the company. Operations will put the ERP at the center of the company. They'll do that in part because ERP systems have been around for a long time. Those were some, the ERP and MRP were some of the first systems to be computerized, digitized, before any of the others. First, it was accounting, and then in addition to accounting, let's start to manage some operations within the plant with the MRP. So it's been at the company for a long time, but it's now high time to move it out. The reason we want to move it out as a node in the ecosystem rather than the center of the universe at the manufacturer is the ERP system can't speak, OPC UA or BACnet or Modbus TCP. It doesn't know the detailed operations of how a machine operates and all of the tags, and it can't extract value from that. It's very good at working on sales, operations, scheduling for production and demand planning, strategy, accounting. It's great at all of that, but not great at the plant floor. One of the other challenges from an architectural perspective at manufacturers is that they'll have these small siloed systems. We've often seen a CMMS, a maintenance system, off on its own, not connected to anything else. They're getting some value. Hopefully, maintenance is moved beyond being very reactive to proactive, at least managing their PMs, their preventative maintenance jobs within that system. But boy, oh boy, wouldn't it be valuable to get data from a machine and have that machine essentially tell the CMMS, hey, I need some help. I've been running high temperature here. It's kind of like us when we're sick. Boy, I'm running a high temperature. I need to see a doctor. Well, wouldn't it be nice if the machine could tell you that too and communicate that to the doctor through this maintenance system? The fact that systems are set off on their own as silos is a difficult challenge. When companies want to start to get into connectivity, sometimes what will happen also, so a third kind of challenge, is that IT departments will come in and say, okay, you have this plant floor of machines. We're going to connect to every single one of those machines, and we're going to shoot that data right up to the cloud into a data lake. And then we're going to do all kinds of modeling, and we're going to do all kinds of analytics. The problem is the people on the plant floor and the production supervisors, the plant managers, don't have access to that data. IT is usually the guardian of that data and doesn't want to let anybody have access to it, or they can't because of the infrastructures that they've set up. So this connect all the machines to the data lake, send the data up, and it just sits there. And nobody really gets any real value out of it. That's another one of the architectural mistakes that we see companies do. If they could, why not connect all those machines, get the data into some organized system? It doesn't necessarily need to be on-prem. It can be on the cloud, but let's set up some kind of data hub so we can communicate the data and then connect and allow other systems to subscribe to that data so that that operator standing on the plant floor can actually see a big TV screen or a tablet that has valuable information for them. How many parts have I produced and how many do I need to go? What's the temperature of this machine and is it running too hot? What are the conditions for the batch that I'm running? And are those conditions within the recipe that I'm trying to run? Let's make sure that we're running to recipe so we can increase quality and reduce the rework that we have to do on this batch. And one of the other challenges too, from an architecture perspective, is proprietary systems. It's vendor lock-in. There are a lot of good PLC companies out there, but those PLC companies have made a lot of money over time and said, there's value in that data. Let's write some software. And that software, they will say, you must buy our software because you have our PLCs. That's the only way you can get value out of our PLCs. Excuse me. So they will almost force you to purchase their software. But their software essentially just locks you into a contract that you don't want to get into. And if you wanted to pull data out of that software into some other system, forget it. Ain't going to happen. They've locked you in. And they've locked their hand into your wallet or into your purse as well, which is kind of unfortunate. So let's work with open systems that are scalable, flexible, and affordable.
Yeah, absolutely. It makes a lot of sense. So You've spoken about unified namespace at length, both on this call and on some other pieces of content, unified namespace that you've put out there, incredible sources of information regarding the unified namespace. I find that a lot of professionals struggle to grasp the UNA's concept. So maybe if we could take some time here to kind of try and drill into this, can you give us like a description of what the unified namespace is and how it works?
Sure. So again, the unified namespace, to start off with, it's not a product. It's not a database. It itself doesn't store data, depending on how you implement it. There are multiple ways to implement it technically, but typically it doesn't store data. And it is, so that's what it's not. And I'll talk a little bit about what it is. It is a concept. It is an architecture. It's an idea of how to connect systems and organize them. So conceptually, again, it's a single hub. It's a single place to go. Again, my palm, center of the hand, will be that single place to go. And it would be a hub for communicating data from all the systems in the plant: ERP, PLC, LIMS, WMS, CMMS, all the systems that you can think of, all the 3- and 4-letter acronyms that you can think of within manufacturing should connect to this place. And that data should be organized to represent the model of the business, of how the plant operates. So the unified namespace then becomes that single place where you can always get information about what's going on in the plant in real time right now. That's what the unified namespace is. And that's the conceptual or idea about what it is. Below it, from a technology perspective, if you don't mind, I'll talk a little bit about the technology side of things. Yeah. The technologies we put in place are typically an MQTT data broker, and to connect to all of the machines, and then a system to be able to connect to all the transactional systems. The way that you communicate to a machine is far different from the way you might connect to a transactional system like a CMMS, a maintenance system, or an ERP system, where they have databases, relational databases at that often, and APIs and other ways to connect to them. So very often we need two tools to do that communication, but that unified namespace can exist between the two tools because of how we're structuring the data. So HiveMQ is a good data broker that we like to use a lot. HiveMQ can then be set up with the MQTT Sparkplug-B specification to enable us to structure the data from each of the PLCs and send it into the data broker. Once that data is published and lands in the data broker, we can set up other systems to subscribe to that data, like an HMI or a data visualization tool or an MES system. And they will, or a historian. I haven't even mentioned a historian yet, like Canary Labs or some other historians that can communicate via MQTT. So they will then subscribe that data and then be able to work with it and do what they need. So is the data stored within the unified namespace? No, but you can get the current state at all times. And based on the fact that MQTT is report by exception and edge driven, it's effectively an event-driven system, then other systems will be able to pull and subscribe to and get the data from that hub. So if a historian needs the data about a PLC and to be able to capture all the tags for the PLC, that historian can get all of that data through the unified namespace, rather than creating a discrete connection from the PLC directly to the historian. The fact that we're providing that data from its source to this unified namespace then allows us to build that model of the plant. And then because we're able to publish data back from one of those other nodes back into that unified namespace, like the MES system, calculating OEE and pushing it back into the system, then we can have some other data database or data source or other system like a business intelligence tool subscribe to that data. So again, it's this concept of single hub, current state of everything, and the model of the business implemented with a data broker like HiveMQ and a data ops system like HiByte, for example, then allows us to make all those connections to all those different systems, the telemetry systems, the machine systems, as well as the transactional systems. I'm not sure how much farther we should take the conversation from a technical perspective, but I think that might help explain it a little bit.
Oh yeah, certainly does explain quite a lot. So yeah, you have mentioned quite a number of tools there that could be used for implementing the unified namespace. Is there like some other tools that you think are worth mentioning here as far as the implementation of UNS is concerned?
Yeah, there are other tools where companies are in the early stages of using some of them. Some companies are using Kafka to good effect for connecting, maybe not directly to the machines, but once the data gets out of the machine and into the namespace, and they want to stream that and integrate that with other systems. Kafka is often used to connect to the unified namespace and also to use to connect to the transactional systems and get the data into data stores. So Kafka has been used from time to time. We know of some implementations of the graph database and using GraphQL as an API to connect to data stores, where you can use the nodes and edges structure within a graph database to define the enterprise site, area, line, and cell, and how the operations work. That's another technology that has come into play. And I'm thinking what else? I mean, there's a whole set of questions around hosting solutions with Docker and Kubernetes in the cloud, and that's a whole other ball game and a different set of technologies. I think some of the other data brokers like EMQX are a good option to work with. One other thing I think I should mention too, one question that often comes up, and this then gets into other technologies, is brownfield development.
Okay.
So if we're building a new manufacturing plant and we're setting up all new PLCs, then we're going to make sure that we get PLCs that communicate MQTT Sparkplug B, or that we can get a device that can translate. But if we're working with old machines, existing PLCs from Siemens, Schneider Electric, Rockwell, whatever they are, those systems aren't going to communicate via this MQTT Sparkplug B protocol. So what we'll do is to use other devices to, if you will, intercept or connect a hardware device or a software device that we'll use to connect to that PLC, pull the data up, connect to a Modbus TCP or BACnet or whatever it is, or OPC UA, and then translate that data to MQTT Sparkplug B, and then forward that data on to the data broker. So there will be a pull response process. Talking about another architectural challenge, which I forgot about. One of the problems with architectures that some companies put in place is they use OPC UA or other pull response type technologies, and we use some of those proprietary software to communicate across networks. But when you're working with OT and IT and the DMZ, the demilitarized zone in the middle, very often you have to set up extra security to be able to communicate between one of the devices down into that network. You have to have extra firewalls, extra servers, and you get into a whole the extending and continuing to use the Purdue model, which can be very expensive for establishing security. You have to have a firewall with holes poked into it to allow you to have access down to the plant floor. Why not instead use protocol that allows for edge-driven data coming up one direction? No holes need to be poked in firewalls. Get rid of all that extra heavy security that addresses issues that don't really exist now. You can still have an extremely secure system and allow data only to originate from the plant floor into the DMZ, which then ends up becoming much more secure. Now, That's one of the challenges for architecture. I wanted to address that from one of the earlier questions. But let's then come back to this question about um, other technologies that came to mind. So let's think of this Brownfield device, this Allen Bradley PLC. Maybe we have, let's say, a Maple Gateways, I think it's called a CMT01 or CMT02 gateway device that has drivers on it to connect to that Allen Bradley PLC, to that Complex Logics or whatever PLC. Then we can take that data in the Maple Systems gateway device, translate it, and then push it up as MQTT Sparkplug B. We can do the same thing with an Opto22 Groove Epic device. Really, really nice, smart PLCs, runs Linux, Node-RED, Ignition, Edge, and other tools. Really nice devices. PLC plus essentially a computing device, secured at the edge with two network connections, two NICs in it. Really nice device. We use those devices often, thinking about technologies, to get the data, pull response from the PLC, and then translate it to MQTT and push it up to the network. We'll often use Kepware too, from PTC. They have 150 plus drivers to connect to a bunch of devices. We'll put that on the network or onto an edge device like an IPC, an industrial computer, and then push that data up as well. So a lot of other technologies and last minute thoughts that I had, hopefully filling in a few gaps.
Oh yeah, absolutely. That's really helpful. Now, when I'm just thinking about this whole thing, you can see that this is like sort of a paradigm shift, in the way that communication normally happens in the industrial setting. So when you look into the future, what do you see as being the future of MES in manufacturing?
I have two or three thoughts on that. In the short term, I see the big monolithic applications going the way of the buggy whip, essentially not being as popular or common for a couple of reasons. One, companies, manufacturers are tired of these big, expensive, risky projects that too often don't work out. Those implementations of a monolithic ERP system, or excuse me, MES system, often go as well as that last ERP upgrade or implementation that you've had in your manufacturing company, and very often they don't go well. So because of those challenges, I think that monolithic approach is going by the wayside. Progression of technologies these days, the fact that we're able to create these open networks with unified namespace and these technologies like MQTT, Sparkplug B, et cetera, and we have a lot more tools at our disposal, like Factory Studio from TatSoft, Ignition from Inductive Automation and others. We can now build our own tools and templates and then implement those and then start to, and because we have very direct ways to communicate with other best-in-class tools like REST APIs and other methods, then at that point, it's a more straightforward process to create that patchwork quilt of best-in-class tools to solve the problem. So where I see MES systems going in the short term is more patchwork quilt, best-in-class tools to solve the challenges. The real question is, are the manufacturers going to are they going to think very short term and say, I need a production monitoring system, and then it presents them with a glass ceiling over their head, and then they can never achieve more? Or are they going to implement something where they put in a basic architecture and then build on top of that architecture? Think of building a building. I'm going to start a new company and we're going to grow like crazy. I'm going to buy this little plot of land that is good for a house. Well, that's going to last me, for a little while. But what if I want to build an office building and house all the people that work, or the manufacturing plant? I need more and more space. And I didn't think about that. Let's buy at least a reasonable amount of space, make sure it's zoned well for what we want to do, and then we can grow into that space. And that's what that architecture does. So that's another piece of why I think it's going to be really important for the future of MES. I'm going to step back a second and talk about what I started with, which was companies need to solve these short-term challenges, on-time delivery, quality, production, etc. And what they really should be doing is also thinking forward. Start small, but think big is a good phrase. They should be thinking big too for solving those bigger challenges around inflation, competition, etc. And the way they do that is by, again, implementing a good architecture that is scalable. That's out of scalable, affordable, and flexible. Scalable is the most important word there. Let's think about connecting not just our ERP system, ERP, plant floor ERP system. Let's think about connecting our whole enterprise, this plant plus all the other plants. Enterprise has that data. Now let's think of a little bit further. Let's connect to our customers. Let's actually connect with our customers, not verbally on a phone call or a virtual call. Let's actually connect with them via data. Let's connect with our suppliers. Let's get better data about the quality of the products we're getting, and then let's give them that feedback real time. Let's create this network, this ecosystem across companies, secure. And it's not impossible to do. It's not rocket science. Let's create this secure ecosystem connecting our customers and our vendors. Now let's think about the data we'll have in our hands. We have a lot of data in our in Industry 3.0 and the PLCs that was never really used. Now we're going to use that data. Next step is to use the data across our plant with all these different systems, exponentially more valuable. Now let's connect our whole enterprise, even more value. Now let's connect our suppliers and our customers. It's mind-blowing, the value. And at that point, if you're using the right tools, you have the right structure, data is modeled well within the unified namespace, getting into AI and machine learning, not a difficult venture at that point. And then the value you can extract, recognizing patterns, forecasting, all that kind of stuff is huge. We can now start to think in a different way. The guy that I've connected with, worked with, and read his books, Bruce Sinclair, his IoT Inc. book, IoT book is really, really good. He takes the perspective of an OEM, original equipment manufacturer, manufacturing their products, putting them out into the world. Let's get more data from those products as they're out in the world. We work often with OEMs and also end user manufacturers, but his ideas apply to both. And those ideas are, if we have this data, now we can start to innovate, and we can even invent. We can drive new products. We can now start to think about how we sell our products and move from being a services-based company or a product company to a services company, to an outcomes kind of company. And we can actually start to change how we sell our products. For an OEM, think about the fact that if you're selling a big machine, and that machine cost, I'll use US dollars, cost $500,000. There's a big capital expenditure process, requisitions and submissions process, and approval process you have to go through to get the buying a new machine approved. What if that manufacturer of that machine knew how that machine was used, knew it so well that they could actually work with you and say, hey, let's sell this machine to you based on the number of products that you produce. Let's actually provide you with just a monthly expense. So it moves from purchasing as a CapEx on the balance sheet to moves as a transaction I can buy with my American Express card. And that expense shows up in the income statement. And I don't have to go through this big, massive expenditure and approval process. What does that mean for that OEM? And what does that mean for the manufacturer? Easier to get the right assets in place, better connection with your customer, tighter relationships. Everybody's winning at that point. It's huge, the kinds of business model changes you can make. That's really long term, but when we talk about the future of MES, there's a future of the MES to think about for the patchwork quilt and architecture, but let's also use the value of that architecture, that unified namespace, to do so much more, to really connect suppliers, customers, create that ecosystem, and really drive differentiation of the company in the market, to drive changing business models, all that. It becomes mind-blowing. I get excited, so I'll step off the soapbox. Sorry about that, but it's exciting stuff.
Fantastic. Yeah, it's certainly exciting indeed. Certainly exciting. So to conclude this session, Can you tell us about Ectobox, the company of which you are a CEO, and what solutions do you provide to the industry?
Sure, absolutely. As a company, we like to think of ourselves as a manufacturing intelligence solutions company. Given everything we've talked about, it's about getting that intelligence, that data from the plant floor and working with it in these kind of architectures. So that's what we do. And when we're doing that, we're looking at the manufacturers and thinking about how we can help them operate more efficiently and grow. And again, we do that by connecting to machines, people, other systems, single version of the truth, give the visibility, real-time visibility into the plant floor. And very often we're working with those manufacturers to start off by, again, solving the issues around downtime, helping them figure out what their OEE is, breaking out the components of OEE so they can see what's going on, helping them with maintenance, on-time delivery, et cetera. And very often we end up talking with a lot of people in operations and maintenance across the whole scheme. And most of the work we do is machine connectivity, connect to brownfield and greenfield devices, and get that and set up that unified namespace and connect it to existing systems that they have. And also we will get into projects where we are actually implementing MES systems, of course. Again, of course, starting off with work order management, downtime, OEE, scheduling, some of the initial pieces. We are getting into doing a lot more custom development. Some companies will come to us. We understand manufacturing really, really well. We started off many years ago as a software development firm. So we understand data and software really well. So companies will come to us for creating very unique custom software applications within manufacturing as well, to replace existing old systems. In fact, we're looking at a couple projects now where we're going to replace some systems that were built in COBOL, which is pretty old. Yeah, exactly. And the other thing that we get into is we're now starting to build a set of products, including a production scheduling system based on the theory of constraints, drum buffer rope, and have these products available that will connect into the whole unified namespace, and they will be best-in-class products within the umbrella of an MES system.
Awesome. Yeah, so that brings us to the end of this session. Thank you so much for taking the time out to come and share your insights with the community, Kevin.
I really appreciate your time. Thank you so much, Kudzai. Really appreciate your time. Appreciate it. It's been fun.